getting to our last talk. So Yuhanxiao, can you please what's it called? Go or turn your full screen on, and I'll get out of the way. Okay, there's your screen. And before you start, Yuhanxiao, let me just crop the slideshow, and then we will begin.
Okay.
Okay, and let's change the camera so we could see you. All right. And for our last talk in games and the last talk of tonight, it's Yuhanxiao Ma on DQN Playground for minigame Aircraft War. And it's super cool talk. And she also just posted the website where it looks interactive and it's really cool about the game that she built for the talk. So can't wait to hear this. All right, Yuhanxiao, we're ready for you.
Okay, thank you. Hello, everyone. I'm Yuhanxiao, and I'm a Chinese student just graduated from high school. And I'll be learning economics and interactive media arts in the coming semester in New York University. And thank you, Joshua, and all the other people that worked so hard for this great event. I'm so honored to have such an opportunity to be here and give this presentation. So, actually, what we've done is not a typical research. It's just a project that helps myself and other beginners in reinforcement learning to get a better image of what is going on in networks and how we should adjust those hyperparameters during the training process. And as you can see, the title is a DQN playground for minigame aircraft war. So that means you can mess up with almost all the settings in the training process to see what are the things that are going to happen. And firstly, let me briefly just introduce the reinforcement learning and DQN. Reinforcement learning is a kind of learning algorithm that can train models without any data sets. So it enables machines to automatically learn to do specific tasks. And before explaining DQN, I will give an intro of Q-learning. It is a simple yet quite powerful algorithm to create an exact matrix for the working agent. This helps the agent to figure out exactly which action to perform in order to maximize its reward in the long run. And in deep Q-learning, we use a deep neural network to approximate the Q-value function. So it's deep Q-learning is better for more complex scenarios. And what is Aircraft War? It's actually a minigame released on WeChat. It's like Twitter in China back in 2013 by a Chinese IT giant company Tencent. It was very popular and influential in China at that time. And Josh, could you play the first video for me? Okay. So the rules of this shooting game are pretty simple. You can move up, down, left, and right to avoid the enemy aircrafts and shoot them as many as possible to win high marks. The bullets are fired automatically at a certain frequency, so you only need to determine the position of your aircraft. And the game does not end unless you're hit by your enemy. As an interactive media art student, I regard machine learning as one of the most full of potential applications in making arts. So I just wanted to learn more about it before I officially study in university. And that's one of the reasons I made this platform. And during the process, I found that video games are good for evaluating the effectiveness of their algorithms because the scenario is just complex enough and the rules are clear. So it becomes easier for the agent to iterate. And of course, it's also good for demonstration. And why visualize the learning process of DQN? because the reinforcement learning process just hard and non-intuitive for most of the beginners like me, so that's why I want to visualize it. And on GUI, all the hyperparameters are adjustable, such as observations, learning rates, reward decay, etc. And then we could intuitively see how the training process and outcome will be affected by those hyperparameters. And then let me introduce the whole structure of my codes. So due to time limit, I will not discuss about the DQN thoroughly, but I will quickly share with you what we did in this project. My Python codes are based on the two sources below, as you can see, the reproduced source code for the game, Aircraft War, and also the DQN code sample. So what we did first is basically changing some parts of their codes and building a bridge between the game itself and DeepQ network. In short, it's just applying DQN to train the agent in the game Aircraft War. The state of game, including observations and rewards, is given as the input to the DQN, and the Q value of all the possible actions is generated as the output and sent back to the game as a final action of the play, no matter if it goes left, right, up, or down. So it works in a kind of circulated way. Observations, as you can see here, is basically the normalized relative coordinates of your plane and your enemy. And reward is like if you stay alive, it will be the score at a specific frame. Your score times a certain reward ratio you set. And if you die at that frame, you will get a negative value for award, which means it's a punishment. The second thing we did is to make a GUI that displays crucial data, including optimizer hyperparameters and model-specific hyperparameters. And at the same time, it will send hyperparameters back to DQN to modify the whole structure in this Python file, altering the training process. And furthermore, the action will return back to the game, and the game will then be influenced. Josh, could you play the second video? Yeah. So this is basically the look of our graphical user interface. The column on the right are hyperparameters you can adjust. And the two graphs on the middle respectively displays the training scores and loss function. The upper left box updates the changes in hyperparameters, and the bottom on and the box on the bottom left updates the scores of each game. You can check my GitHub page for the source code. And during the testing period, I found out some interesting and reasonable phenomena. Like if you set the reward very high and punishment very low, the plane would just dash around madly, trying to shoot many enemies without worrying too much about whether itself is going to be hit by the other enemies. And for the opposite situation with a low reward, high punishment, the plane will adopt a loss aversion strategy. It would rather dodge than attack. And the third one is that with hyperparameters unchanged for a while, the trend of loss function is generally decreasing, which seems to be a good trend. But the previous things we've done are based on Python codes. It means that if you want to see the GUI I made, you must clone my whole Python GitHub repository. But what I want to do is make it more accessible. That's why I decided to build a similar thing with JavaScript based on a website. To be honest, I actually have almost no prior learning experience in JS, but luckily I found a project made by Sean999. So I learned how he built his network with TensorFlow JS and modified it according to my ideas. And this is the website, DQN Bagel. I can give you a quick look. And I would like to thank all the people I mentioned about. They are enthusiastic sharers, no matter for the Python versions or the JavaScript version. Without them, I can never make a prototype that conformed to my ideas so quickly, right after my high school graduation. So I'm greatly inspired, and I really want to be a developer and artist with this kind of open source spirit. At last, I like to call for help for my further work. This is a kind of website that supports crown training. That means um, there are limits to what one person or one laptop can do. But what if all users that use this website can train the networks on their end, contributing to the training process? So the website will automatically record the highest training result and related settings for each game. So there are several games to choose from, and as well as networks. You can just select the ones you want and adjust those hyperparameters. Uh, so if you're interested in it or want to collaborate with me, please contact me. My Twitter account is vmaggie, and my email address is maggie_mayu at fermic.com. And thank you all for listening, and feel free to check my code on GitHub and also the website.
That was a wonderful talk, Yuhanxiao. Thank you for giving
Oh,
that talk. So I'm wondering, like, I guess you just kind of like gave what your next steps are, like that you want to build this platform so people can compete and to see which machine learning model can get the best high score in the game. But I'm wondering,
yeah.
like what if you have like any other interest for reinforcement learning, like is there anything else you want to use it for or experiment with, or what do you think you want to build next?
I think I'm going to build some kind of physical agent that can put this network into it. Like if you want to build a small toy, it will learn how the human will interact with it. If the person in front of it is sad, maybe it will play some music to comfort the person. Or if you're excited about the toy will just say something to talk to you. It's like building this kind of um, physical toy to help those or have some mental um, illnesses or something like that. That's just my general image. I just wanted to apply reinforcement learning in my future artworks. Yeah.
Very cool. Hold on, let me give you a clap. Let me see, is anybody else still in the Zoom room? uh, yeah, so does anybody in the Zoom room want to ask anything or say anything before we finish up?